I'm going to show you how you can create a game similar to Flappy Bird, where if I run it, you know, it's just kind of like this, just the mechanics of Flappy Bird, but you can replace it with your own artwork if you want. So the tools that you'll need is Unity. You can download that from unity3d.com. Once you install Unity, run it, close that. Go ahead and create a new project, and you're gonna do a 2D game. So switch to 2D right there and browse to a new folder. I'll just call it example. And make sure 2D is selected, and then just click create. I don't care. And then wait for it to load up. I created some notes right here for me to follow along so I don't get lost. So the first thing we're going to do is create the main game scene and then create a game over scene. So let's set up our folder structure. Call it scenes. Let's create another folder. Call it scripts. And we need anything else? Let's create another folder. Call it game objects. Okay, so let's save this scene. Whoops. Save this scene into the scenes folder. Just call it main. And then let's create a new scene. Save it to the scenes folder, and this will be our game over scene. Now go to File, Build Settings, go to Add Current. Actually, start with the main scene, double click on main, go to File, Build Settings, go to Add Current, close it, double click on the game over scene, File, Build Settings, Add Current. So now we can reference these levels in our scripts. Okay, double click back on main scene and check my notes. Okay, let's go ahead and create the player now. So for the player, I'm just going to create a sphere just because I don't have time to get all that artwork and stuff. So since this is a 2D game, right click on the sphere collider, remove component. We'll be using a circle collider 2D instead. So go to add component, physics 2D, circle collider 2D, and go up here, go to tag and select player so that we can reference it in the scripts based on the tag. You can rename this if you want. Right click, rename. I'm just going to call it player. Oh crap, I can't spell. Player. Okay, and let's click on the scripts folder, right click, create C# script, call it player script, and then click on this player object and then drag player script onto the component section, and you should see it appear right here. Okay, so let's run it and see how it looks. Should just be a circle in the middle. Okay, good. And let's give it a rigid body so that it has gravity. Rigid body 2D. And now you should see it fall when you run it. Okay, my stupid microphone went out again. That's the second time while recording this. I'm getting kind of mad. Okay, let's get back to this. Okay, now let's make it move forward. So double click on player script. Wait for MonoDevelop to open up. MonoDevelop comes with Unity. Yeah, a different solution was open. That's why I got an error. Just close off that other solution. Okay, so in player script, okay, my microphone is not working well. Okay, let's go void fixed update. And then let's go this dot rigid body 2D dot velocity equals new vector 2. Let's give it a constant speed, so let's create a variable. Let's give it a float, public float. Let's just call it max speed. Give it a default value of like 5. You need the F because it's a float. Okay, so for the X value, we'll give it max speed. And then for the Y value, we'll just leave it at the current Y velocity. So go this dot rigid body 2D dot velocity dot Y. Control S to save. Go back into Unity, run it, and it should move forward now, forward and down. Yep. Okay. Now let's handle jumping. While you hit the space bar, you want it to jump, right? So let's go here, create another variable, public float. Let's just call it jump force. Jump force. And let's just give it an initial value of like 400. You might want to play around with these numbers. Just keep trying it and play around with it. So we're gonna go into the update, and we're gonna go if the user hits the enter key or the space bar, then you want to add Y velocity to the player object. So go if input dot get key down, open parentheses, key code dot space. So that's just saying if the space key, if the space key is pressed down, then we want to add the Y jump force to it. So go this dot rigid body 2D dot velocity, no, go dot add force, open parentheses, new vector 2. The X value will stay the same, so go this dot rigid body 2D dot velocity dot X, comma, the Y value will be the jump force variable. Close parentheses, semicolon, Control S to save. Go back here and test out the space bar. Okay, it is jumping. Now, one thing we want to do is make the camera follow the character. So let's right click down here, go to create, C# script. Let's call this camera script. And click on main camera and drag camera script onto the component section. And now double click on camera script and go to mono develop. Let me close all of these other ones. Okay, now we need a reference to the player's position. So go to public, transform, player. Control S to save. And if you go to Unity, click on the main camera, and you'll see that under camera script, you'll see that you have a reference to the player transform. Drag the player object onto this script right here. So now that we have a reference to that in our script. And now in update or fixed update, whichever one you want, void fixed update. The only difference between update and fixed update is that, I don't know, look it up. But you want to do your all your physics stuff in fixed update. So we want this dot position, nope, this dot this dot transform dot position, there we go, equals player dot transform dot position. So basic, no. Yeah, basically we want it to follow wherever, well, we just want to follow the X value. So new vector 3, the X value will be this dot X, there we go, and then 0, comma, and then for the camera is going to be out towards us, so we'll go about -10, and there we go. Let's see how that looks. There we go. So now it's, whoa. Okay, well now at least it's following. Now we have to fix the jump. What it's doing is continuously adding force. So I want to reset it every time so that we have a constant Y value jump force. So I'm going to create a new vector 2. call it no y velocity equals new vector 2. The x value will be the same as its current, so this dot rigid body 2D dot velocity dot x comma 0 for y velocity. And then I want to set this dot the current velocity, so rigid body 2D dot velocity equals no y velocity. Now when I add the jump force, it'll be constant. So let's test that out. Yeah, so now it's the same every time we press spacebar. It's the same y force that's being added. Okay, next thing we need to do, see, create player. Okay, make player, move forward and jump, fix camera on player. We did that. Now create the upper and lower bounds. Okay, so let's create that, the ground and the upper thing. Create other. Let's just go to quad, and then go to scale in the X direction. Let's see, 5, let's see, 10, 20. Yeah, we just want it to fill up the screen. Let's see how that looks. See if it fills up the whole screen. Yeah. Okay. This will be, let's move this down. This will be our ground. Let's just put it to an even -5. We can rename this to ground. And we want it to also follow the player, so we can just put it under the main camera and it will go wherever the camera goes. So if we click play, yeah, then it's staying with the camera and you can see it on the bottom right there. The other thing we need to do is delete this mesh collider, because that's for 3D. Give it a box collider in 2D and select is trigger, so that when the ball hits that, it will trigger the script, and we'll create that later. But let's first create the upper bounds. So go to create object, create other, quad, scale it to about 20 again, the same as the ground. Position it to +5. Rename that to like ceiling or something, and place that under main camera as well, so that it follows the camera. And let's see how that looks. Okay, delete that mesh collider, add physics 2D box collider, also add 2D rigid body 2D. Play that. Let's see if it detects a whoops. Whoa. Okay, forget rigid body 2D. And let's see if, okay, now it's colliding with that. For the bottom one, it's triggering. See, we didn't do the is trigger for the top one, so it's directly colliding. For the bottom one, we set it to is trigger. So let's take care of that right now. We're gonna create a new script, call it ground script. Open that in MonoDevelop. Okay, so for this script, we want it to be if the player object collides with this ground object, we want it to go to the game over screen. So we need the function on trigger enter 2D, and it takes a collider 2D. We can just call it other. Okay, so we want to check if the other object is the player object. So we'll go if other dot tag equals player. Remember, we set the player tag when we created the player in Unity up here. That's why we wanted it to reference in one of these scripts. So if other dot tag equals player, remember the two equal signs because it's a comparison, not an assignment. So if it's the player that's colliding with the ground, then load the game over screen. So application dot load level to 1. I think that'll work. Now it's 1 because remember when we added the scenes in build settings, this game over screen is 1 right there. So let's see if that works. We're going to collide with the ground. Nope. Okay, let's see what we did wrong. I set it is trigger. Okay, let me pause and try and figure out what's wrong. Okay, I'm back. Just figured out what was wrong. Very simple. It's forgot to link the script to the ground object. So drag this, be sure that the ground is selected, and then drag ground script onto the component section. Run it. What? On trigger enter 2D. That goes there. This is selected. If it's unselected, like that, so select it. Come on. Okay, I'm gonna pause it, see what's wrong. Okay, I figured it out. All you had to do was add this return right there, and it should work. So if I click play, and it hits the ground, and then it will pop up and be this empty game over screen. So now that we have that figured out, the next thing we'll need to do is create the little obstacles that you have to fly through. So I'm just gonna create and stack cubes for those. So you can go cube, delete the box collider, because that's 3D and we want 2D. So go to physics 2D and box collider 2D. Select is trigger because we want it to behave similar to the ground, where if the player crashes into one of these, then it will go to the game over screen. And then go to scripts, right click, create C# script, and call it, you can just call it block script. And then with the cube selected, drag block script onto its component section, and we'll program that later. But for now, let's just create the different obstacles. So with the cube selected, hit Control D like 3 times to create 4 of them, and then create empty, an empty game object to stack it in, and then just drag one of them down like right there. Drag this one down a little more. Drag this one down to the bottom. So now this is kind of like one obstacle where you have to fly up over this in between right there. So select all of those and drag it onto the empty game object you created. And now under here, select the game objects folder, right click, create prefab, call it obstacle 1. Let's start at 0 since programmers start at index 0. Create like, we'll create like 5 of them. Obstacle 1. Let me see if I can just duplicate this. Control D. Yeah, Control D duplicates that. So now select this game object and drag it onto obstacle 0. Select all these cubes, just drag it out, and select this top one right here, put that on the top. So now you have to fly through that. Drag it back onto game object, put it in obstacle 1. Do the same things for obstacle 2, 3, and 4, where we just move it a little bit just to create different obstacles. Drag it on there, drag it down here. Move this one up here. Select all of these, drag it there, right there, and then last one will be like that. Okay, now we created all of these. You can delete this now because we have them all right here. Okay, let's look at the notes. Let's see what's next. Spawn, create obstacles. Yep. And then spawn obstacles. Okay, so let's create a spawn objects which will randomly choose one of these and then create the object in the game screen so that you have to fly through it. And for that we can just go to game object, create other, and we can just use a quad, drag it over here, let's rename this to spawn, because that's going to spawn all of these objects, and move it to under main camera so that it follows the main camera. And let's make sure it's out of the game screen. Okay, good. So it's out of the game screen. With this selected, go to scripts, right click, create C# script, and call it spawn script. And with this selected, drag spawn script onto this right here. Okay. And now open that up. We still have to program the block script. So let's do that right now. We want it to behave exactly the same as ground script. So we can just copy this into block script. Paste that. Control S to save. And we'll test that in a little bit. So go to spawn script. We're going to create a public variable to store the game objects. So go ahead and type public game object, and this is going to be an array of all the game objects that we created. We'll just call it game objs. Control S to save, and you'll see that when you click spawn, under the spawn script, it now has a variable called game objs. So go to game objects and drag each one of these onto that variable. Okay. Now what we want to do is in start, we want to say create a random object in this array. So what we're going to do is we're going to create a new function, just call it spawn. And then we're going to go invoke, or we can just call spawn right away. Spawn. And then in here, we're going to create a random game object in that array. But first we're gonna say invoke spawn every 2 seconds. So every 2 seconds it's gonna call itself and create a random object. So let's program creating the random object right now. How we do that is we call instantiate game objs, and now comma quaternion dot identity. Is that rotation? Oh, we got to do the vector first. New let's see, let's do this dot transform dot position. What the heck? This dot. Well, we'll worry about that later. Let's choose the random object in here. So it's 0 through the size of this array minus 1. So we'll do random dot range, and we'll go 0 through game objs, it's case sensitive, objs dot size, no, length, there we go. And this range function already handles the length minus 1, so we don't have to do minus 1 here because it's exclusive. 0 is inclusive, and then this second value is exclusive, so it already handles the minus 1. Okay, now we go here, comma, the position will be this dot transform dot position. There we go. And then the rotation will be quaternion dot identity. That just means no rotation. Okay, save that and let's test it out. Should be random objects. Okay, it's working. Random things are being created. Now, if you notice, things are being created but not destroyed. We don't want it to run out of memory, so we have to handle that and delete these objects that are being created. So to do that, I think we can just go into update. No, let's do it in block script. That makes more sense. And go in the start menu, the start function. Start. We're going to tell it to delete itself after being created, after about maybe 4 seconds. So we're going to say destroy this dot game object after 4 seconds. And And if you notice, each of these blocks individually are under a hierarchy fashion. So we have to also delete the parent. So we're going to say if this dot game object dot dot transform dot parent, we're going to say if it has a parent, then destroy the parent, else just destroy this game object. I don't know if this is correct, but I'm going to leave it at that. Say destroy this dot game object dot transform dot parent dot game object. Okay, let's test it out. I think I also need to add the 4 seconds. You know what? I'm gonna do it a little differently. Delete this. And I'm gonna go void destroy and copy all of this into here. Control X and then Control V, and I also need a void right here. And then I'm gonna go invoke destroy after 4 seconds. So after 4 seconds, I'm going to call destroy and destroy the game object. So to test it out, to see if it's actually destroying, I'm going to first go 1 second and see if it's destroying after 1 second. Yep. Okay, those things are destroying after 1 second, so we know that this script is working. We can put it back to 4 seconds to make sure that it passes the whole screen before it destroys. Alright, we're almost done. Next thing we need to do is calculate the score and then do the game over screen. So for the score, let's create a new script. Create C# script, score script, and let's just put it on the main camera. So select main camera, drag this score script to its components, and then open that up. Okay, now we're gonna create a private variable. Let's just do an int, call it score. We can give it an initial value of 0. to calculate the score, well, every time you pass an object, you get a point, but I'm going to do it a modified, easier way and just calculate the score by time. Because if you notice, for this example right here, every time you pass an object, it takes about 2 seconds. So I'm going to say every 2 seconds we're going to add a point. So for that, I'm going to go score plus a sign time dot delta time divided by 2. And I believe delta time is a float. So I'm going to typecast this to an int. Put another parentheses around this whole thing. And then I have to display the score. So for that, you need the onGUI function. And for the location of the score, we're going to add a new label. So go GUI dot label new rect. The position will be, we'll have to play around with this position. So go 0, 0. This I think is in the top left corner, but we'll try it out. We'll give it a width of maybe 100, height of maybe 30. For the content, we'll display score colon end quote plus our score variable. And the IntelliSense didn't work. Let's just try to score. There we go. Okay, let's see if that displays the score. Nope, we got compiler errors. We got unexpected symbol. New. Let's see what line number. Score script line, I think that's line 20, unexpected parentheses. Right here. Oh, we forgot the semicolon. Okay, let's see if this goes away. Yep. Okay, let's run it. Okay, score is up there. That's a pretty good position. I don't think it was adding. Okay, microphone shut down again. Okay, what I was saying was the score was not changing, it was remaining 0. So let's take a look. Okay, I think the problem is that it's dividing by an integer. So let's change this to a float. Okay, I'm back. I'm just gonna do it a little different and just leave it as a float here. So time dot delta time divided by 2. And then in here, I'm gonna go int. Now that should work. Okay, microphone got cut off again. Anyways, what I was getting at is on disable is called whenever the scene's about to change, when it's ending. So we want to store the score here, and we can just store it in the player prefs. You don't really want to create a separate file and store it on the hard drive or anything like that for this simple game. You can just store it in the player prefs. So player prefs, there it is. Player prefs dot set. We can set float and give it a key name. We can just call it score. The value will be score, the score variable. Stupid IntelliSense. Score. Okay, so we stored that. Now all we have to do is do the game over screen. So make sure you save this scene and go to scenes, game over. Double click that to load it. Go to scripts, create a new script for this. We can call it game over script. Double click to open this. Microphone again. Okay, so we were in the game over script. We don't need any of these. We just need the onGUI function, because we're just gonna output some stuff like the score, and then we're gonna output a button saying if you want to retry and load up the original level. So void onGUI, and then GUI dot label new rect. Give it a position. We're going to put it in the middle of the screen, so we're going to go screen dot width divided by 2. That should be in the middle, around the middle, maybe middle right a little bit, but that's good enough. And then we'll just give it like 30, width maybe 100, height about 30. For the content, we'll just say game over. Control S to save that, and let's see how that looks. So with the game over screen loaded, select play, and tired of this microphone. I just bought it too. Okay, so we were in the game over screen. It didn't show up, and that is because we didn't attach the script to anything. So just drag this onto main camera, and that'll automatically put it in the components, and then view it, and game over should pop up right there. Okay, so we know that's working. Now we want to show them the score. So in start, let's get the value that we stored in player prefs. So let's create a private variable, call it score, give it an initial value of 0, and then in player prefs, get float, we called it score as the key, and we want to assign that to our private variable score. Okay, so now let's display the score. So GUI dot label new rect screen dot width divided by 2 so that it's in the middle. And let's see, the game over was at 30, so let's put this at around 60. Give it a width of maybe 100 and a height of about 30. For content, we're going to say score colon plus the score variable. And stupid IntelliSense isn't working right now, so let's see, score, there we go. Control S to save. And then we need a button to load the original level again if they want to retry. So GUI.label new, no, we need a button dot button new rect, position that below the score, so screen dot width divided by 2 and give it about 90, 100, 30, and then we'll say retry in it. And actually we're going to go if so if you go if this, that means if they click the button, so we're going to say if they click the button, then application dot load level 0. 0 was the initial level, 1 is the game over screen. So Control S to save, and let's see how that looks. Okay, that's good enough. So if we click retry, it will load this again. Got 1, and then I crash. Oh, okay, so we have to display the score as an int instead of a float. So try that again. Retry. Okay, so go over here, past that, I hit it, and I get a score of 2. Okay, so it's working. And now, last thing I want to tell you is if you build it for like a mobile device like Android or iOS, it doesn't have the space bar, so you need to use the microphone again. Okay, what I was saying was if you build it for Android or iPhone, it doesn't have a space bar, so you have to do touch controls, right? So under player script, where you have the if they hit the spacebar key, then add if input dot touches. There we go. And that's an array, so you'll have to loop through it. You can use a for loop, but I think it's easier if you use for each. For each. And then touches is an array of a touch object. So touch, we can call it t in input dot touches. So for each touch in those, if t dot phase equals, you need two of those because it's comparing. Touch phase dot ended, meaning they just lift their finger off the screen. Then add the y velocity. Just like that. So that if they build this for like Android or iPhone, if you build it for an Android, then you also have to download. Okay, I'm almost done. Hopefully this microphone doesn't do it again, but I was saying if you build it for Android, you need to download the Android SDK, and then once you click build, it'll ask you where the Android SDK installation folder is. You point it to that, and then once you build it, it'll output an APK file, and then you just connect your phone to your computer by USB, drag in the APK file into your phone, and then from your phone locate the APK file and install the game, and then you can test out if the jump is working. So I think we're done here.